Ladies and gentlemen, thank you for being here with me today. I'd like to talk a little bit about right triangles and a fun thing that we like to call the Pythagorean Theorem. Just as a quick review, here I have a triangle drawn on this paper. Obviously, a triangle has three sides. We generally call the two shorter sides legs of the triangle, and we generally call the longest side of the triangle, which always happens to be the side that is across from the right angle, the hypotenuse. Now, the Pythagorean Theorem says this. If a triangle is a right triangle, then the sum of the squares of the legs is equal to the square of the length of the hypotenuse. By the way, feel free to pause the video if you need to at any point in time. If you want to write down without me continuing to talk, that might be helpful. That's the great thing about these videos. You can pause them, you can rewind, you can rewatch. So, Pythagorean Theorem. Sounds like a lot. This is really what it means. A squared plus b squared equals c squared. Please remember, the Pythagorean theorem only applies to right triangles. If a triangle is a right triangle, that is the start of the definition of the Pythagorean theorem. So if we have a right triangle, we generally name the two legs A and B. It does not matter which one is A or which one is B. We generally name the hypotenuse C. So if you look at our equation down here, it's pretty simple. Take one side, whatever the length is, and you square it. Take the second side, you square it. When you add those together, they should equal the square of the third side. I hope you'll take my word for that the Pythagorean theorem is in fact true. Give it another year or two and you're going to actually prove it in one of your math classes. But for now, I hope you just accept it. Now, the Pythagorean theorem, it allows us to do three things. I hope you'll remember that because at the end I'm going to ask you what three things the Pythagorean theorem allows us to do. With that being said, let's jump right into an example. First question. Find the length of the hypotenuse in the right triangle. Since we know two of the three lengths, and since we know the Pythagorean theorem, we can create an equation and we can solve to figure out the length of the third side. In this case, since it's the hypotenuse, we are going to be solving for C. So, let's start out by putting our equation down. And now let's just start plugging in numbers. If you want to name this side right here A and this one B, or the other way around, either way works. So plug in 6 for A and you have 6 squared. Plug in 8 for B and you have 8 squared. And we do not know C, so that remains a variable. Let's continue to solve. 36 plus 64 equals c squared. Good thing you know all your perfect squares. Add those together and we have a 100 is equal to c squared. The question is, do you guys remember how to solve these types of equations? If you have a variable that's squared and you want to undo that square so that we can just figure out what c is, you've got to take the square root of both sides, because the square root of a perfect square is just c. Okay? And then the square root of 100 is obviously 10. So what you found here, the length of the hypotenuse is 10 centimeters. So the first thing we learned to do was to use the Pythagorean theorem to find the length of the hypotenuse in a right triangle. In our next example, we're asked to find the approximate length of the missing leg in this right triangle. So let's refer to the Pythagorean theorem once again. We know how it goes. A squared plus b squared equals c squared. Okay, let's name our sides. We always name the hypotenuse c. It's the longest side. It's the one across from the right angle. And we always name our legs a and b. Remember, it doesn't matter which one is which. So let's plug them in. We've got 7 squared. We do not know what b is, so that's going to remain b squared. And we know c is 14 squared. Let's continue to simplify. As I move this up so you can see it a little bit better. It's 49 plus b squared equals 196. Well, we want to get b by itself, so let's get rid of that 49 and subtract it on both sides. So we still have b squared equals 147. Now, just like in the last problem, take the square root of both sides. And you're just left with b equals the square root of 147. Or you could also say b is approximately 12.1 inches. Either one would be just fine. All right, now, one more thing here. We know the Pythagorean theorem is true, but we also know that the converse of the Pythagorean theorem is true. Please don't be afraid. The word converse just means to kind of flip around. So if you look at this statement right here, if the sum of the squares of the legs equal the square of the length of the hypotenuse, then the triangle is a right triangle. All we've done here, I'll bring back our definition of Pythagorean theorem. It's right here so you can compare the two. All that we did was take the first half of this definition and put it at the end, and we took the second half of this definition and we put it at the beginning. So if we take the squares of each of our legs of our triangle, we add them together, and if they do equal the square of the hypotenuse, then we know that the triangle is a right triangle. So let's use this in an example. The question is a triangle with sides of 12 meters, 15 meters, and 19 meters a right triangle? Let's draw this out. We obviously know that we've got two legs and we've got a hypotenuse. It doesn't really matter what your triangle looks like when you draw it, as long as you know it's a right triangle. As long as your longest side, your hypotenuse, is 19, and as long as one of your legs is 12 and one of your legs is 15 meters. Now, to determine whether this is a right triangle or not, I guess I shouldn't have put this in here yet because we don't know if it is or not. We're going to use the Pythagorean theorem. So once again, a squared plus b squared equals c squared. We want to see if the left side is going to equal the right side. So let's plug our numbers in. I'll call this a, I'll call this b, and of course the hypotenuse is c. So 12 squared plus 15 squared, and it's a question. Does it equal 19 squared? Well, since you're so great with your perfect squares, we know 144 plus 225 equals 361. Or does it? If you add these guys together, you get 369. And we know full well that that does not equal 361. So I was wrong at the beginning to put this right angle marker here. You should not have that there. So the answer is this triangle is not a right triangle. All right, folks. So here we are at the end of the lesson. I'd just like to sum it up a little bit and make sure we know what to come in with tomorrow for class. So I did tell you I was going to ask you this question at the end. What three things will the Pythagorean theorem allow me to do? Hopefully each of you is going to walk away from this lesson and you're going to say all three of these to yourself. First, I can use the Pythagorean theorem to determine the length of the hypotenuse of a right triangle. I hope you're asking yourself what are the other two things before I show them to you. Secondly, I can use it to determine the length of a leg of a right triangle. So that means we can use the Pythagorean theorem to find either a leg or the hypotenuse. As long as we know two of the sides of a right triangle, we can always find the third side. And lastly, I can use the converse of the Pythagorean theorem to determine whether or not a triangle is a right triangle. So folks, please come tomorrow with any questions and be able to tell me what you can do using the Pythagorean theorem.